understand, and you can interrupt to align me on what you're expecting me to answer on. With regards to the goals you see in this slide, confidentiality, integrity, authentication, all of these goals could be achieved via the corresponding technology, let it be signature or encryption. The examples we have discussed this morning are all about scenarios where we have different cases of two communication parties, Alice and Bob. They're just acting as a communication party, and it could be any communication party with that regard. With reference to achieving confidentiality, for instance, yes, you could use encryption. You could use secret key encryption. You could use public key cryptography-based encryption. Both of them should work. What you have to now decide is which exact mechanism is the right mechanism based on your use case. So that would be a question on your side. Is that something that you were expecting as an answer?
Yes, sir, I got it. Thank you, sir.
All right, okay. So let's proceed, assuming all of you have no further questions, to a different topic, which is about data masking, something which is quite an interesting subject. And I would like to throw this slide to begin with. If you look at the two images, which are quite prominent here, what do you exactly find as a difference? Let's start with the first image here. And if I compare that image with the other image, what is exactly the difference that you would point out immediately? I think the answer is obvious, but I would like to engage with you. And although it's not mandatory, but if you can keep your cameras open, that would keep this session engaging. So I see 3 students so far with their cameras. If all of you can keep it open, that would be a plus point for the engagement of this session. Now, with regards to the difference, what would you point out as an immediate difference?
In this picture, there is no eyes.
Yeah.
The face
The face is completely blurred
different.
up, different.
Right. Okay. Hannah, go ahead.
No, it was to sell the same. The face is hiding. It's hidden, hidden,
Yeah,
and not the other one.
correct. Roshni, go ahead.
Yes, so we can identify whether it is a male or female in the first picture. That's it, and not the eyes or it is totally blurred. In the second image, we can identify somewhat, but not the
Yeah.
clear face.
Right. Good. Those are all interesting remarks, and I was expecting them because it's quite obvious that the common answer I get from student is that in the first image, we do not see any facial attribute. Now, there are some attributes of the overall face, including hairs and jawline, if you like, but essentially, the core facial attributes are completely rendered what is known as anonymous. What does that mean? That means that the data subject is no longer identifiable because the core facial attributes are essentially not there or not readable or understandable. But if we compare that scenario with the other image, we do have some facial attributes. And what would be your answer with regards to what you see there, as in what character comes to your mind?
It's a female, but the core face attributes are still vague. I mean, I can guess the gender, but I mean, it's still blurred somewhat.
But you do see a face, right?
It looks like the Mona Lisa and then Barbie, so it's kind of
Right.
hard to interpret what it is.
Correct. Yeah, I
False image.
agree with you. If you, yeah, Jade, go ahead.
Yeah, I think it's a sort of avatar, and so we can say that it represents someone, but
Right.
that's the user who choose
Yeah.
the avatar.
Yeah, I do agree with you with regards to how this is managed. What is interesting is to kind of think about the scenario that the image itself has number of data points that you could use to determine the subject. Now, by subject, I'm referring to the individual, the person, or the human that you see there. Whereas in case of the first image, we didn't had any facial attribute except the fact that there is an individual that we cannot identify at all. In the second image, due to the facial attributes available, we could identify the subject, and as um, Ifiok pointed out, this is probably a Barbie character. Now, just a little funny note on the side, I did had some batches where students pointed this out to be Taylor Swift. I still don't understand how that really adds up because that doesn't look really like a Taylor Swift. But um, the fact is that, as also if you was talking about that, it is on facial attributes, a character that doesn't align with the data subject itself, which appears to be Mona Lisa. And this is exactly what pseudonymization is all about. In other words, we do have data points, or I would use the right term, information. Now, be aware, information is not raw data, something that we discussed in the very first session. If you reflect back to the IKW model, you would understand what I'm talking about. The information in the second image is available, but we cannot use that information, for example, the facial attributes, to identify the data subject directly or indirectly. In other words, it provides an image that we could use for our data processing, but we can't rely on that image. And this is where the difference between anonymization and pseudonymization comes in. Now, what is exactly anonymization and pseudonymization? They both are data masking techniques. And what I mean by data masking, obfuscating data into something that doesn't recognize or provide any attribute or otherwise any indication of the original data. Now, this is something, by the way, we have discussed already when we were discussing cryptography or the basics of cryptography, where we, for example, were taking the input value and taking a hash of that input value. The hash itself was a kind of masked identifier because it didn't provide any information about the input value. We also talked about ciphertext, which is encrypted data that also doesn't provide any indication of the input value. So we have talked about different masking operations, in particular to the cryptography types we discussed. But there are a number of other techniques available. And what is important to realize is that the two major classifications of those techniques are anonymization and pseudonymization. In anonymization, we end up with a data that doesn't provide any information or otherwise link that could provide identifying information of the original data. Again, in the image, we do have an image. We know that this image corresponds to some individual, some human being, or a person, if you like, but we cannot identify that based on the facial attributes because facial attributes are completely anonymized. In other words, they are essentially not processable. For us, it's nothing. And this is exactly where the data subject is rendered anonymous. Whereas in case of pseudonymization, we do have the output data, which is masked, but not using a technique like hash or encryption, but any other technique which has resulted in the output data being this image where the facial attributes have been essentially replaced by a different character. which allows us to still process that image. Let's say if we are running an image recognition service, or if you are working with an organization that is training an AI model on different images, this image could be used for that sort of training. But the data point itself would be classified as pseudonymized because of the fact that it doesn't provide the identifying or indirect info about the original data subject. So with these two understandings of anonymization and pseudonymization, let's jump into the use cases. Where do we essentially use them? Or if you are looking at it from the perspective of you working in a marketing campaign, for example, when should you use anonymization and when should you use pseudonymization? In this table, I have listed down first the core concept that you should always understand without any exceptions. And that is that if you have a data set that you want to be reversed, as in you have data that you have encrypted and you want that to be decrypted, then the anonymization technique will not apply. In other words, anonymization is all about performing one-time operations. Think about anonymization as a concept that you would typically apply when you are releasing data to an unauthorized party. It could be, for example, let's say, result of your survey, a survey that you have conducted with your team, and you would like to publish that result onto the internet, but making sure that the survey doesn't include any personal data of the participants. You would then anonymize the participants' data within that survey before publishing it online. And this is exactly where what we would end up with is a data that would not be reversible or re-identified. So that is conceptually what you would be trying to achieve. Whereas in case of pseudonymization, there would always be a possibility of reversing the masked data into its original form. Now, the most common technique you would think about reversing essentially would be encryption, because when you encrypt data, you have a mathematical component, right? That is key. And you can use that mathematical component to decrypt the data. So encryption, with regards to the masking concept, is a technique that is regarded as pseudonymization. So each time you want to have something that you want to get back into its original form, what you would be doing is applying data masking via pseudonymization technique, whereby the masked data or the encrypted data would be reversible. In other words, what level of reversibility we should have is dependent on the technique that we use. So encryption is really which allows us 100% reversibility. We can decrypt the data entirely, but we could have also some algorithms that only provides a level of reversibility, meaning some level of re-identification or identification of the original data. Now, with regards to anonymization, this is quite important because here we are just masking something into something that is not recognizable at all. And therefore, I think you would immediately understand that the target identifiers would be direct identifiers like names, IDs, addresses, or any identifier that could directly identify an individual. And this is where anonymization typically applies. Another good point to note down here, if you are taking notes, is that in practice, when you are dealing with customers' data, and there is a regulation that says that the data should be protected, and you are about to release that data to the public, the right technologies that you should be using is anonymization. You should anonymize the data, because this is where you would ensure that the liability of the law that you have to obligate to is essentially fulfilled, because you have masked the personal data completely. And therefore, this is a kind of a way for you to get rid of that responsibility of the obligation to protect personal data. What I mean by that is if I have a data set that has two columns of names and email addresses, both of these are direct identifiers. and I would like to publish this data, but I don't want to take the liability of masking it to a degree where some of it would be re-identifiable, or let's say it provides some level of re-identification. If you again reflect back to the image of individual with the face of a Barbie character, the point there was that if we want to avoid having such sort of liability where our data is out there and people could make all sort of guesses in the sense, well, this picture is really a data subject, which is Mona Lisa, so it's quite clear that this subject is masked, and we could re-identify that the original subject is identity X or identity Y. Similarly, if I would like as an organization to publish a data set, but don't have to face this liability of data masking where re-identification remains a risk, I could similarly just publish dataset by completely anonymize the identifiers. Now you could think of that as excluding the personal information from the dataset. And this simply means that you are taking away that liability altogether. So in practice, what I wanted to say, which you could take as a note, as I indicated, is that a lot of organizations, before publishing datasets, they anonymize them if they want to not take the liability of still uh, complying with GDPR, as in once the data set is published. Because upon publishing, if there is no personal data in the data set, they have no liability whatsoever. But if they are publishing a data set with some personal data that is pseudonymized, meaning it can be reversed, or there are some re-identification info that could allow people to take very clear guesses, then of course the liability remains. So that's one thing you should take into account. Usage scenario, as I said, mostly one time. So passing data to a third party, or as I was explaining, the fact that where we have a legal obligation to protect data and we would like to get rid of that legal obligation by just masking or taking out all the personal data, either by replacing it with some random data or doing anything else. Whereas in case of pseudonymization, mostly transactional data or operational data that is supposed to be reversed. Think about it as data stored in a database where it has to be fetched back for use. But when it is stored in a database, there has to be some sort of masking, typically encryption, data at rest encryption. And as soon as we fetch that data back from the database, it is decrypted and used by the user or the employee of the organization. Moving further, I have some blocks here that you would see, and all of these blocks would provide some info with regards to what kind of identifiers we have. But I would here ask you to come in. So let me ask you a few questions around. First and foremost, the red box you see at the left side of the screen. What Let's start with this question. What type of masking would you apply to that sort of data points? Anonymization or pseudonymization?
Anonymization.
Anonymization. I agree. Those are direct identifiers. And typically, we prefer to go with anonymization of those direct identifiers. Then we have in the green box some identifiers. What type of masking would you suggest for them?
Pseudonymization.
And why?
Because there are no direct identifiers. We can see just the age and gender.
Correct. I agree on that sort of matter. What is important then, if you are pseudonymizing this data set and releasing it to the public, what would be your risk? Because you would essentially still be within the confines of protecting the data that you are publishing. In other words, if you are pseudonymizing this data, which is you would apply some sort of masking that would not completely take away the information or turn it into unprocessable or gibberish sort of data, but it would still provide some level of identification. If that's the case, and my question is to Narapat, what would you suggest in that scenario to be a best approach? Because given that you have applied pseudonymization, you still have a risk of people using it to kind of re-identify it to the actual subject. Do you get my question, by the way? Yeah.
Maybe anonymize all the data.
If we anonymize all the data, then what would happen essentially is we won't have any usable data. All of that would be gibberish, if you like. Because anonymization is completely masking or making it essentially unusable. Now, this is a type of situation we often deal with. When we talk about utilizing the right type of masking, we ask ourselves, all right, if it's direct identifiers, so in this example, if it's direct identifiers, we would be using anonymization, quite straight. If it's indirect identifier, we would probably go with pseudonymization, because in case of anonymization, we don't want anyone to reverse this direct identifiers original form. In other words, if I'm publishing it as some anonymized data, which is gibberish, I don't want anyone to reverse that back to its original form because it's direct identifier. In case of this data, if anyone tries to reverse it to an extent, that's fine. In fact, that is what I want. This is where I want this data to be usable. And when we have this scenario, there is no good or bad approach. It then all depends on what is the utility requirement of our customer. If our customer says, well, I want this data to be published in a manner where the accuracy should allow the recipient to understand that the age here is between two different points, as in between 30 and 40. Now, this is a type of utility that is what we would have to abide to. It could be that for gender, the requirement for the client would be to keep it as is, not change it at all. But when it comes to company, we should mask the information entirely, as in we should make sure that the company itself doesn't reveal anything. Otherwise, the risk of re-identification would be very high. So this is how your mental process would be. You would look at the data that you would have to mask and go by data point and data point alongside what is the expectation of the customer. And based on the utility requirements of every field, you would apply the masking accordingly. Now, what exactly are you trying to achieve? You are exactly trying to achieve that in a situation where someone could essentially combine these indirect identifiers with any of the direct identifiers, it would be difficult for that individual to identify the data subject, which means you would try to pseudonymize the data to a level where if that pseudonymized data is combined or attributed with identity data, direct identifiers, it would essentially make it difficult for the recipient to identify the data subject that this data corresponds to. And this is where the suggestion that we typically has is that depending on whichever anonymization technique you prefer to apply, make sure that the desired level of utility is aligned with the requirements of the customer. In other words, if you are, for example, publishing details of the stats you have collected on your customers, and your task as a sales or marketing team was to analyze the buying trends in different regions, your result of final report should not include first and foremost any PII, but if there are indirect identifiers that you might have to include, for example, the name of the region, you may have to be a bit specific, as in the exact address in some cases, which is not normally what you would deal with, but let's say IP addresses in the digital world is what would be there. Now, IP address could be regarded as a PII or a personally identifiable information as long as there is another data point in the same set that could allow the recipient to identify that IP address in relationship with any other data point, as in combine it together to identify the subject. So we have to make sure, or you would have to make sure, that the utility of the anonymized data set is exactly on a level where it doesn't compromise one of the two. So in scenario I was talking about, if we have to identify different regions as precisely as possible, we would like to include them, but make sure that if we are listing down an IP address and the region, that entry within our report doesn't include any other data point that could also end up in combination of all the data points and leading up to the exact identification of the subject. And it is really where you are adjusting the masking, as in what should be the right level to reduce the possibility of someone exploiting this data. I will give you some examples as well today, but another important point to note while we are discussing this is that the indirect identifiers are regarded as quasi-identifiers. So I would be rather using the term quasi in the future. And this is what you should also use in your report, in your presentation, or whenever you would document your work. Now, when we look at it from the perspective of, let's say, essentially the use cases that we have most of the times, I already told you in this slide that pseudonymization is where we typically use conceptually to allow some form of reversibility, some form of identification. But what is important is that this level of re-identification, or how much information we should expose, is based on the purpose of processing activity. As I was telling you in the previous slide, it depends on the customer's requirement. But if you want to be more concrete, customer would have multiple requirements that would relate to different processing activities in your digital system. And within that digital system, based on that processing activity, you would have to essentially decide the level of pseudonymization that should be there. Now, personal data, for example, being used for transactional operations, or any operation that would include fetching or storing data in a database with columns and rows, a relational database, that would involve also some kind of pseudonymization. I told you about an example that data at rest could be encrypted, so that if the database itself is compromised, we would have some level of confidentiality. But when we have to fetch the data back from the same database for our processing activity, we have to decrypt it. So reversibility, and this is quite common, but in the same slide, I have listed down a number of other techniques. In other words, I would like to just point out that there's not just encryption, masking, there are a number of other techniques that you could use. But what is important is that you know exactly what this technique corresponds to. And I would do the same by going through one of them, well, each of them, in fact, and ask you whether it's anonymization or pseudonymization. Again, remember the concept. Anonymization is all about one-time operation to convert or transform data into something that is no longer usable or identifiable. It should not be reversed, no reversibility. Whereas pseudonymization is all about transforming data into something that could be used to a degree of utility that is desired with our requirement or aligned with our requirement. And this is where we could typically reverse it back to the original form. With that in mind, if I start with scrambling, obfuscation, something quite common, I would say, because I have seen students doing it all the time in their spreadsheets or storing data locally. And that means if there is an identifier direct identifier being the name of the subject, this could be replaced with some kind of scrambled or obfuscated info. Now, in this case, what do you believe this to be the type of masking? Anonymization or pseudonymization? Take a guess. It's not an exam. Yeah, Parvez, go ahead.
It's pseudonymization.
Pseudonymization, all right. And why do you think it appears as pseudonymization?
It has characters like K, C. So
Yeah.
name can be used some characters of the name.
Yeah, some gibberish. I would say some gibberish that doesn't really say anything about the input data set, right? But you're suggesting pseudonymization, which means you are suggesting that this could be reversed back to the input form.
Yes.
Okay, that's fine, no problem. What is important to note down is it depends on the technique. If I have to take your suggestion, I would assume that you have scrambled this input value using a technique, for example, encryption, that would allow you to decrypt this data back to the original value. All right? I think you lost me there, Pervez. You lost my answer, unfortunately. I won't repeat it if you're not connected, but let's go to the next point then. Encryption and hashing. Here we are quite specific about the technology. The example is again a direct identifier. The output is some gibberish. What do you think? Let's start with encryption. Is it anonymization or pseudonymization sort of masking?
It's
Well, I guess this is also pseudonymization.
Okay, why?
Because the text, which is like the name, that can be reversible.
Why technically? If it's encryption, it is reversible, and that is because what did we learn in cryptography?
Because of the cipher text which we
Yes, that
use.
there is a key that we used, a mathematical component that we call a key that we use to encrypt data, and we could use a same key if it's secret key encryption or a different key if it's public key cryptography to decrypt the data, right? So it's a technical reasoning that is important. Are you following? I don't see you, so I don't know if you're
Yes, sir.
nodding, not nodding. All right, okay.
Yes, sir.
Hannah, you also raised your hand, I saw.
Yes, I thought it was anonymization
Why?
because there is the first name, the last name, and the credit card, which are in the last example,
Yes,
anonymization.
but it is encryption. If you're suggesting that the technique here is a technique that is based on anonymization, you are saying that it's a one-time operation and this text cannot be reversed back to the input value. But if the technique is encryption, then we know that technically there is a mathematical component key that would allow the reversibility.
Yes.
So from that perspective, it is where I would rather say pseudonymization, because pseudonymization allows reversibility to the original data, whereas anonymization doesn't.
Okay. Okay.
Let's go to the hashing, the next technique. This is interesting. What do you think about hashing? Is it a technique that allows pseudonymization or anonymization?
I think hashing is 100% anonymization.
Who is it? Parvez? Is that you?
Yes, sir.
Okay. So you're saying it is pseudonymization.
Anonymization. Hashing is 100% anonymous.
Anonymization. All right. And why is that? I mean, what's the technical reason?
The reason is that in hashing, we know that data cannot be reversed back,
Right.
and anonymization is
Perfect.
completely
That's all I wanted to hear. It's a one-time operation, as in it's a one-time transformation. The output should not be reversed back, and this is exactly what conceptually anonymization is. So hashing aligns with the anonymization concept, whereas encryption aligns with pseudonymization concept because it allows reversibility. Now here, the example, we can go with any of them because the output is gibberish. Hash also produce a gibberish result, and ciphertext or encrypted data does the same too. About substitution or shuffling, if you look at this credit card number, I have essentially substituted X, well, essentially the value 1 with X, and I have shuffled or swapped uh, the two digits 97 to 79, which gives me this output result. What kind of mechanism or masking do you think? Yes, Hannah?
No, I just have a question about
Mhm.
hashing. You say that it allows reversibility also, or no? Like it's a anonymization?
About what? About hashing or encryption?
Yes, hashing.
Hashing doesn't allow reversibility. No.
Okay, so it's anonymization.
Yes?
Yes, okay. No, just to be sure.
Yeah,
Okay.
yeah. So hashing is something that aligns with anonymization because it doesn't allow reversibility, whereas encryption aligns with pseudonymization concept because of the fact that ciphertext or encrypted data could be decrypted. Um, for substitution and shuffling, any remark? Which type? Yes, Hasnat, go ahead.
Anonymization.
Pseudonymization.
Yes.
Okay.
Data can
And
be
what is your
anonymized.
technical reasoning behind that?
We can
Hasnat, what is your technical reasoning behind your answer?
recover that
Okay. All right.
by
Right.
using external.
Okay. So we can reverse this output value back to the input value, the original credit card number, as long as we have access to this matching table or this matching criteria. Would you agree,
Yes, sir.
Hasnat?
Yes, sir.
Okay, so what is important here that yes, it is pseudonymization because there appears to be a fixed criteria by which we are performing the substitution and shuffling. And this means we could categorize this as pseudonymization as long as we have access to the matching values or the matching table. All right. You can also, by the way, if you are not sure, you can acknowledge your response with an emoji like this, you know, something like this. This is also something that would confirm me that you are aligned with what I'm talking about. Okay.
Yes.
You can acknowledge this okay with an emoji. Right. I see one only, but it is what it is. With regards to tokenization, uh, we have now again an input value and the output is gibberish. But with regards to tokenization, what I can tell you is that there is a matching table, something I was preparing you for when I was talking about the matching keys here or matching values, is that with the tokenization concept, what we end up is with a matching table where we would say, well, this number, input value, corresponds to this exact output value, and this matching table entry is what we would keep to ourselves. And we would only publish this output value. Now, if that is the case, uh, what kind of masking technology do you think it is? Same question. Anonymization, pseudonymization. Perhaps let me pick you this time. So Zubai. My apologies to everyone of whom I have pronounced the name wrong. Now, what do you think, Zubai?
It's a pseudomization
Okay,
because it can reverse.
correct. Great. Because there is a matching table, and as long as the party has a matching table, it could reverse. We could regard this as pseudonymization. Then we have blurring, as you could see, also known as approximation. By the way, if you look at the literature, there is another term that is used for this masking concept, and that is generalization. It's not written here, but take a note if you like. Generalization, approximation, blurring, they are more or less what you see here as an example. So if this is the age, we could present this age as above 30. Now, again, if we are maintaining our matching table for this kind of mapping, then the concept would align closely with pseudonymization technique or pseudonymization based masking. But if we are not maintaining any sort of a matching table like this with these matching entries, and we are just publishing this one time, then it would align more with the anonymization concept. All right. Are we all on the same page here? Any questions? All right, I see some acknowledgements. Now, here is a table I have prepared that essentially allows students to connect different dots about data masking. What kind of dots or what kind of concepts I'm talking about? Well, primarily the two classifications of masking types. The first one being anonymization, pseudonymization. Then within anonymization, we have two main categories. Any technique that uses random data, as in by adding noise. Noise is a technical term here that involves adding random data to the data set. And this is quite interesting because this allows the data to become as in mixed with random data to a level where we would regard it as quote unquote noisy. Noisy in the sense that it is original values mixed with random values, and the result is essentially anonymized data set based on randomization concept. There are some concrete techniques about this. Permutation, for example, is all about where we essentially combine different numerical data or numerical values in a manner that results in the output which is quite random. This is typically based on grouping the data together by performing certain actions, but that grouping involves adding additional random data or performing the grouping randomly. This typically has high utility requirements. Noise addition, on the other side, is more about adding more and more random data. There is also a very interesting algorithm that you may like, because this is the algorithm that all of your Apple devices, let it be your iPhone, iPad, Mac, or iMac, they use differential privacy to apply masking on all the heuristics or usage data collected on your Apple devices. What I mean by that is when you, for example, unlock your iPhone, how many times you are unlocking your iPhone, how much time you are spending on a specific screen, how many times you are swiping a certain screen from one to the other, what is your typical screen time, what kind of applications you are typically minimizing, what is the random or an average minimized time depending on the use case. All of this data is collected by Apple as usage or heuristics based data. And Apple claims that it is masking that data in your device using differential privacy, which is a mathematical concept that utilizes a function known as epsilon to add the noise into the data. Without going into the technical aspects, differential privacy is quite a well-known algorithm. We use this in a lot of other use cases because it is typically a suitable or a preferred data masking approach for big data categories. So in the age of AI or machine learning, we are dealing with a lot of data, and differential privacy is only getting more and more used in different cases. I can also name some big names like Uber, who has been using differential privacy, Microsoft, and you could find number of major examples online. With regards to generalization, there we would not really add any additional data. What we would do is essentially group or combine the existing data in a manner that would provide anonymization. So techniques involve aggregation, where we would typically combine different values together by grouping them as a patron. Patron could be, for example, domain name, name of the protocol, and the port number. These are some attributes that could be there for an entry like the website address or the domain name. But the way we combine them or aggregate them is essentially dependent on multiple choices. There are many out there, but this is where we apply the generalization concept. We then have a specific mathematical techniques based on certain algorithms like k-anonymity, L diversity, and T closeness. L diversity and T closeness, by the way, are variants of k-anonymity. We would discuss k-anonymity actually in particular, but these are some mathematical concepts allowing us to achieve generalization, and it's suitable for big data. And then in the second part, we have pseudonymization, where we typically don't have these kind of subcategories because the data is reversible. Remember, reversibility. And of course, encryption is the most common technique. You can reverse the data. Now, this is problematic because there I say hash, and I just told you in the previous slide, hashes are one-way function. They cannot be reversed. So what are we really talking about here? Why hash? Any idea? All right. Without giving you much trouble here, the hash here is actually a special hash that I highlight in the bracket. It says HMAC. Now, MAC is message authentication code. In other words, it's an algorithm that is based on symmetric cryptography, or what is also known as secret key cryptography. So this algorithm, MAC, secret key cryptography, uses hash as a part of its masking process, which means if there is a secret key cryptography algorithm involved, this sort of hashing would allow reversibility because the algorithm would essentially be based on a secret key cryptography that would entail some action or a step where hashes would also be used. This means it is reversible because it's based on secret key cryptography. And secret key cryptography, as we know, is reversible. We use one key for both encryption and decryption. So what is important to note down here is that when I say hash, I'm referring to a special type of algorithm that uses hash, but that algorithm is based on secret key cryptography, hence reversible. Okay? Just to be sure, because this is something I feel could trouble some of you. So can you confirm if we all are on the same page here? Okay, I got one acknowledgement. Right, few more. Now, lastly, tokenization, as we discussed in the previous slide, it is typically about having a matching table, but the use cases are different. With regards to HMAC, we typically go with scenarios where we need a fixed length value, as in the output value should be based on fixed length. Tokenization is mainly where we prefer the output data to be of certain format. Think about tokenization typically when you are dealing with programs, online programs, or cloud services that allows you to mask data, personal data, with regards to storage, where they would have a mapping of a personal data with a storage value, and the storage value would be compatible with the type of storage. So tokens would be generated accordingly if a storage type is a certain type. Whereas in case of hash, we don't think about storage format. We rather think about the algorithm that is being used, which would decide what would be the length of the output, what would be the character set of the output, and so on. So that's where it differentiates with tokenization, where it's more about the storage level format rather than which algorithm we use. All right. At this case, I have to admit that all of the masking types that we have been discussing and the concepts that we have essentially talked about are quite interesting, but at the same time, very important to be able to apply them in practice. Yes, Shinmaya?
I just wanted to know, there are how many type of hashing? Like you said, one hashing where data cannot be reversed, and the other type, just you mentioned HMAC 256, which is being used for the secret key function type of. So there are how many type of hashing?
Right. So there are no real types of hashing in the sense of what you are asking. There is only one hash category, that is keyless cryptography, which is one-way transformation. But in practice, we have number of other cryptographic techniques like public key cryptography. If you remember what we were discussing during signature generation, the process of signature generation using public key cryptography involved first generating the hash value, right? So similarly, in HMAC, the process of encrypting data involves generating a hash value. This means that the process itself is using hash, but hash itself is a concept that is always keyless by default, as in always one-way transformation. There is no exception to that, okay? It's only the name of the types of techniques or algorithms that may use the hash as they like. So HMAC used the hash as one of the steps in its operations. Signatures using public key cryptography use hash as one of its steps. So that is all about using that hash, not really the type of hashes. Okay? Is it okay, Shinmaya? As far as to your confusion went?
Yes.
Okay, so hashes, no types. It's just keyless cryptography. We could use hashes in different applications, and it depends on the application itself. HMAC is an application where we are using hash. But to be precise, HMAC itself is a algorithm, a cipher, which is based on secret key cryptography. But in concept, it is using hash as one of its operations. Similarly, for public key cryptography, where we generate signatures and so on. Hannah, go ahead.
Yes, I'm sorry. It's only because it's PET or in the instruction of section 4. Just a question when you talk about solution, because I think it will be this also with cryptography and PETS. Do we have also to talk about the 7 privacy by design fundamental principles in solutions?
Not necessarily.
Okay, so it will
In
be only on
solutions,
cryptography and PET.
in solutions, you have the option to discuss any relevant solution throughout all the slides, not just cryptography, masking, or privacy enhancing technologies, PETs, which I will discuss with you now. It's your choice. So it's not necessary to talk about the 7 classic fundamentals of privacy by design. You
Yeah,
can
I can
refer
do
to
it.
them.
Okay.
Pardon?
Okay. I can do both. Okay.
Yeah, you
And
can, for example, if you are suggesting a solution where the processing activity was uh, storing email addresses, all right? Just an example.
yes.
In this processing activity, if you're proposing a solution that we should anonymize the data before storing, then of course this is a concrete solution and you would have to describe what kind of anonymization would it be. Should it be based on randomization, generalization? What should be the name of the technique? If you are interested, you can go deeper. And then you could also refer to the fundamental principles where you would say, from privacy by design perspective, anonymizing or masking data before storing it aligns with the idea of essentially reducing the risk, which is something that aligns with the first principle, which was proactive, not reactive. In other words, taking necessary measures without waiting for something bad to happen. Here, you would mask the data before storing it, so you are taking all the measures even before storing it. Does that example provide
Yeah.
more
No, it's
clarity?
clear. Yeah,
Yeah.
it's clear. And also,
Okay.
just one question about section 5. When you talk about masking data, and we have to do it with all the column. Which column are you talking about?
Well, I would come to that.
Oh, okay. Thank you very much.
Yeah. So with regards to the masking itself, all the techniques that we have discussed, in this slide, I would like to state very clearly that those are very good techniques. In other words, extremely important when you would be performing section or not section. Activity number 4 out of the 4 activities we discussed earlier, where you would find solutions. So you would be masking data based on crypto concepts, based on masking concepts. But at the end of the day, it is agreed upon by professionals that it is a very difficult process, because I have here a quote I took from one of the companies which is quite famous within the market of data masking. The name of the company is Aircloak. And the quote I took from one of their publications was, as is the case with IT security, no 100% guarantee can be given, and often there is the need for a risk assessment or essentially risk analysis. The reason they are making this claim publicly is because they are very well aware that regardless of whatever masking technology they may use, the process would still be quite difficult to guarantee 100% privacy. In fact, there is no such thing as 100% guarantees. And coming from a provider like Aircloak, this tells me that whatever you would mask, at the end of the day, you would still have a level of risk of re-identification. You won't be able to really provide 100% guarantees, because that is almost, I would say, impossible in scenarios depending on what we are doing exactly. But what I could provide as a suggestion here is, in practice, what you would be doing is combining different types of technologies together. So we were talking about digital signatures using public key cryptography. We saw that digital signatures combine the hashes, keyless cryptography, and public key cryptography. And upon combining both of them, what we ended up with is a digital signature. Not only that, when I gave you the open exercise and I proposed a solution, all of you essentially were following that. In my proposal, I combined public key encryption with hashes. So I encrypted the data. I also signed the data, which involved taking a hash. And each time I'm combining different technologies together, what I am ending up with is known as a privacy enhancing technology, or PET in short. So each time you hear the term PET, think about a technology that combines different techniques together. All right. And there are some examples I can give you. As far as I could find, there are two categories, and this is where it may make it simple for you to understand that all those privacy enhancing technologies could be based on the criteria of whether you as an end user should put trust to a third party. So if you are supposed to trust the service provider, for example, you are visiting a website and you don't know whether the data when you would visit the website, as in your internet connection that would take the data from your device all the way to the service provider, whether that data would be protected or not, you don't know. Essentially, you would have to trust the service provider to implement something like secure socket or transport layer security to provide those privacy guarantees. Similarly, when your Apple device is collecting data from your device, which you may find problematic or not, it depends on how you view that sort of collection. But essentially, Apple is claiming that don't worry, we are masking that data to an extent using differential privacy, which is based on the randomization concept of anonymization masking type. And this is where you would have to trust Apple that they are doing it correctly, which is quite questionable because there have been some reports out there which claimed that they are not doing exactly what they are publicly claiming. And Apple has faced criticism on that in the past as well. But the point is, any privacy enhancing technology that asks users or require users, in fact, to trust the service provider is something that we would regard as a soft privacy enhancing technology. The hard or the second type is essentially where the user cannot trust the service provider or any other party to achieve any sort of privacy guarantee. A good example is onion routing, which I think I would talk about in one of the slides, but there is also secret ballot, which I don't know if you have already heard, but it is quite close to what you do when you vote. And that means when you cast your vote, your personal identification is something that is never involved in the voting process. In other words, you can trust essentially no one to achieve that sort of guarantee. In secret balloting, the personal data of the voter is not even included into the balloting process. And this is where the algorithm essentially works in a way that it uses zero knowledge proofs and sophisticated concepts that involve mechanisms by which the user doesn't have to trust essentially the service provider. The whole process itself is built in a way that user would not be sharing personal data at all. Now, point being that as long as the user has no need or requirement to trust the provider or any party to achieve any guarantee, then the privacy enhancing technology involved would be a hard privacy enhancing technology. And at the end, I have here 3 criteria points that I have collected to provide suggestion to the students, because I have received remarks in the past where students says, we have been masking a lot of data, or we have had this project where we masked the data, but as you have pointed out in your course, it is often very difficult to provide guarantees that this masked data would not be re-anonymized, or sorry, not be re-identified or not be compromised when we would publish it. What sort of questions we should ask ourselves when we are thinking that the data set we have is properly anonymized and is ready for publication? Well, I point them to the suggestions made by European Data Protection Board in one of their opinion papers. This is the official reference of the opinion paper, and it points out 3 criteria. One, is it possible to single out an individual from a larger group? If your data set has, let's say, 100 entries, is it possible for anyone to single out an individual out of those 100 entries based on unique attributes. If that is the case, then do not consider your data to be anonymous. The second point is it possible to link two or more records together in the same data set that pertains to the same individual? For example, in the data set, you may have data about the same individual multiple times, and if it appears multiple times, it opens up the possibility of linking them together. And the result of that linkage could be the individual being found. Then we have infer unknown information about an individual, and this is essentially about a case where you have a data set that has an entry that allows an adversary to use that entry to infer additional information. For example, the background of the individual, the aspects of certain sort of beliefs of the individual just by looking at some of its attributes. So any sort of scenario where we have an entry in an output data set that allows an adversary to infer additional data point about an entry just by looking at the attribute which is exposed in this data set. So with all of that, one special exercise, well, more or less an engaging exercise I have with all of you is to talk about the k-anonymity, which is part of the generalization, anonymization, masking, because students often think, how do we go about them in practice, as in what exactly happens when we, let's say, receive them or have a requirement to apply them in practice. I would be showing you an example of a production application that some of you might have already used. I'm not sure exactly, but that is my guess. And the name of the website is Have I Been Found? Is it? All right. This is the website. How many of you have used this website already? None of you? All right. Now, this is a website that allows you to check whether your email address appeared in one of the publicly available breaches of compromised data. So you can type your email address, click on check, and it would check whether that email address was part of one of those breaches. It would give you some details as well about those breaches. But what I'm interested in is another function that it provides, which is passwords. And here it asks me if I want to check whether my password has appeared in any of the data breaches or public data breaches, as in that have been made aware to the public or made available to certain individuals of the public. I can just type my password, click on check, and it would tell me whether it is already there. If it's already there, it is essentially an indication for me to not use that password because it is not a good practice. It's not a good practice because password reuse is a common issue. Unfortunately, a lot of people just reuse the same password across different platforms. So if you have one password that is already available in data breaches that people could access, this means that people could use that password to brute force your account or try to guess the password of your account, because adversaries just combine all those data breaches together to make one very large dictionary or a table of known passwords. This technique is known as credentials stuffing. It's not written here, but you could have a look at the guidelines by NIST on this subject. My issue is, yeah, it's written here, credentials stuffing. My issue is that on one side, I'm providing my email address so that the website could tell me if it's compromised or not. On the other side, I'm providing my password. Isn't that something that rings some problematic bells? Would you be comfortable in providing both of them? So I don't think Yeah, I got at least one response. I don't think most of you would be comfortable in providing both your email address or password. Even if it's just password, some of you would say, well, I won't do that. I agree with you. But the owner of this website says, do not worry, we have been applying k-anonymity, a data masking technique based on anonymization, specifically, uh, if you remember, it is generalization type of anonymization where we would make sure that your exact password would not be exposed to the backend. And if I look at the slide, it says it is based on a mathematical understanding that the K here of the technique K anonymity corresponds to the number of individuals having the same quasi identifier as in the same indirect identifier in the data set. And the process is pretty straightforward. Uh, on the website, upon providing the password, the website would compute the hash of this password in the browser, as in locally within the environment of the user device. And upon generating the hash, the application would only send 5 digits or 5 letters of this hash to the backend. And these are the digits or characters that would act as the quasi identifier for the backend. So let's try to simulate that in practice. I would open at the bottom just a list of all the network activities so all of us can monitor what exactly happened. Let me write down the most secure password in the world being 1, 2, 3, 4, 5, 6, 7, 8, 9. And as soon as I click on check, indeed, I get a result that says that this password has appeared a ridiculously high amount of times in the public reaches. But let me analyze exactly what happened. So if I look at the URL, I see that the URL is made using a type of HTTP request known as GET, where all the data is part of the URL. So there's nothing in the body. Body is always empty. Now, if I look at the URL, the path has 5 letters. And this is exactly where I could confirm that my browser computed the hash of this password and only took 5 digits of that hash or 5 letters of that hash to send it to the backend. So I can confirm that. Now let's have a look at what the backend responded. By looking at the response, I see a very long list of hashes. Now this is a list almost 1274 hashes, let's say around 1300 hashes, that has those 5 letters. In other words, those 13 or around 1300 hashes have the same quasi identifier present in them. The same quasi identifier being the 5 letters that were sent by the front end to the back end. And this is exactly where the backend guarantees that there is essentially at least k-1 hash collisions. What does that mean? That means that there is at least more than one quasi identifier based value available. Let's have a look at an example to understand this even better. If I look at this response, the backend is essentially taking these 5 letters and looking across the complete database of all the hashes and returning a list of around 1300 hashes that have those 5 digits in them, which means those 5 digits are the quasi identifiers that are available in all of these hashes. As in, backend has at least more than k-1 hash available that has the same quasi identifier, which aligns with the definition of or mathematical definition of k-anonymity, that there should be more than one identifier that would have the same quasi. And in this case, I have the backend having around 1300 identifiers with the same quasi of 5 letters that were sent. And if I actually scroll this down, I could even find out the exact hash, because if I look at this very large value, I see that it is noted here as a part of this hash. So this is actually the hash of the password I typed, which my browser computed. And I have read the API documentation. It says that after the colon, the number represents the time of occurrences in the breached databases. So if I see this number here, then I can confirm exactly that it was this hash actually. But our browser received the complete list. Upon receiving that list, since it already knew the hash, if I go back to the slide, it already knew the hash it computed. It can now match that hash with the list of hashes that were provided. If there is a match, then yes, the result is our password did appear in one of the breaches, and essentially with a number of how many times it appeared as well. But from k-anonymity perspective, this workflow confirms that the result here that we see is k-anonymous. Why k-anonymous? Because the backend only obtained 5 letters or the quasi-identifiers, and upon checking their database, they found around 1300 hashes that had those 5 letters. And this is where k-anonymity definition was met, as in there were at least more than one or k minus one, if you like, quasi-identifiers. Collisions are essentially where we have the same hash appearing multiple times. So there is at least more than one cases where the same quasi-identifier based hash was present. And this is where the complete list of those hashes are sent to the front end, where it is then matched locally. So the final result displayed to the user is a k-anonymous result, and the site is quite fast. If you noticed, my overall response was provided in only few milliseconds. It didn't even take a second to complete, only few milliseconds to get that complete response. In fact, only 48 milliseconds for sending and getting a response back in 35 milliseconds. So it's enormously fast and it's quite straightforward. So let me come back to you and bring you to the discussion. First, did you follow what I just explained? If so, you have any questions or any thoughts? Right, I got one confirmation. All right, few other acknowledgements. All right, if there's no other question, then good. The point is, when you would be using k-anonymity, you would have to set the value of k. In this case, the value of k is set to 5 characters. But in practice, the higher the value is, the higher the private result would be. So it's important to always go with a higher value of k if you prefer to have more anonymous result. If you want to have less anonymous result, go with a lower value of k. I have here another interesting technology, but this is hard privacy enhancing technology where we have what is known as onion-based routing, where we essentially, I don't know if you have already used it, but how many of you have heard about Tor as a network or essentially an overlay network? Any of you? Okay. But what is interesting here with a privacy enhancing technology like onion routing is that, as the name implies, being onion, there are different layers of connections. And a user would have to connect to the first layer, which would be the entry point, and the connection would be routed to multiple layers upon finally reaching to the exit layer. So this would be entry, and this would be exit. Upon reaching at the exit node, the connection would arrive on the service provider side. But the service provider would not see the actual IP address of user. The service provider would see the IP address of the last exit node. So in other words, the connection of user is being routed through different layers. And this is how we are providing the anonymity of the IP address. The issue with this approach is that it is prone to certain sort of analysis attacks, for example, timing analysis. So what we have today is a new mechanism that is also being supported by a funding by the European Union under the project known as Panoramics, where we are using an existing technology based on a concept known as mix master, mix minion, where the idea is basically based on introducing noise or introducing additional random traffic to the data as soon as it arrives at every single layer. So what I mean by that is if I take into account this same case, I could now again route my connection through different layers. And if I'm routing my connection from first layer to second layer, each of the routing step would not only change the IP address, but also it would add additional traffic, noise to that traffic. And this means when my final connection would arrive at the recipient side, the recipient would also have to deal with a lot of additional packets, which would make it very difficult for any adversary or any um, party to analyze and make sense of the timing of the connection, which is where it becomes a high latency network. High latency in the sense that it allows the transmission to take place quite slowly. It leads to high delay. Latency is in the context of delay, but with the advantage of making it very difficult for any adversary to analyze the incoming and outgoing traffic and make sense or compare the timing to somehow figure out the original IP of the user. Now, regardless of whichever type of overlay network, Tor or Panoramics, what is important is to note down that the user, when using this kind of overlay network, is not trusting the service provider. For example, here when the user was visiting CNN.com, the user was not trusting the CNN.com to mask his IP address. The user was simply trusting on or utilizing a network, an overlay network, which is a different technique. So as long as we are using a different technique or any other mechanism without trusting the service provider, then that mechanism qualifies essentially as a privacy enhancing technology. So this is a little discussion I wanted to have with you around the topics of pets. I have here an exercise which is essentially the second module that you have been assigned already. And in this second module, you're expected to perform now section 4, where I would need you to use your existing knowledge of cryptography, data masking, and privacy enhancing technology. Do not forget OWASP Top 10, the very first slide I talked about. And once you have a grasp of all these discussions, you should propose applicable solutions for the threat you outline in section 3. It has to be related with section 3 threats. Then section 4 is about data masking. Here, you are supposed to use your existing data set that you have opted for your project, your group project, all 10 of them. Yes, you are supposed to provide solutions for each of the issue you identified in section 3. So you were supposed to have at least 10, and I'm therefore expecting at least 10 proposals in accordance with the corresponding threat. If some of you have had identified threats more than 10, of course, you would have to identify or propose solutions accordingly. Section 5 about masking your spreadsheet for the project that you have. Make sure you mask it based on a utility requirement that you believe would be sensible. In other words, I have kept, let me bring this here more clearly. I've kept let me just bring you side. So in case of section 5, you are required to use Excel sheet. I'm not expecting you to use any advanced tool or any complicated tool, but an advanced or complicated tool would still be acceptable. However, if you can simply mask the spreadsheet, that would be sufficient for this purpose. I have here a link of um, a link by Microsoft that talks about different techniques that is supported by Microsoft Spreadsheet. If you're using a different tool for spreadsheet, for example, OpenOffice or LibreOffice. So for example, I use LibreOffice personally in my day-to-day use cases. I don't use Microsoft's Excel much, but regardless of the tool that you use, you are supposed to mask the spreadsheet you have for your project, and it all depends on what is your requirement. Would you like to mask the data set completely? Now that would not be very sensible. I wouldn't appreciate that much, because otherwise you would have to justify why this is really something that aligned with the client requirements. So you have to essentially in section 5 think about a potential scenario where you are supposed to pass this data set to one of the clients you may have in the context of your project or in the context of your company, essentially, depending on what type of customers you may have or a third party that you may have. So just to give you an example, if my project is about fitness and I am essentially using a third party where an AI or machine learning algorithm is used to provide some suggestions, and that third party is not part of my system, as in my infrastructure, but it essentially is some sort of a link that I have with that third party. And the context I am then taking is to anonymize the data for that third party. I would have to ask myself what should be the utility percentage of that third party. If it's an AI or machine learning unit that requires a level of data, how much data they would need, and I can adjust my masking accordingly. So think about a scenario that is suitable within the context of your project, and you would have to explain that in section 5, as in this was my use case scenario, this was the utility requirement, and this is how I masked it accordingly, right? Yes, Hannah.
Yes. First, the deadline is on Monday, right?
Yes.
Okay. And can you talk about the column? Like, do you have an example of what you expect us to do?
I expect you to just mask your spreadsheet. What do you want me to show you exactly
The
by
column, like,
what column you have? And all of you have different spreadsheets, as in based on the project you selected.
okay.
I don't know, maybe I'm missing your point, but
Yeah, no, I
you
don't really
want an output data
understand.
set, for example?
Yes, please.
Okay, I can show you something, but again, be aware that that would have no meaning,
Yeah, yeah.
because it's based on whatever concept you would take, huh? So it should not be interpreted as what I'm expecting. But let me see if I have uh, here an example from one of the other courses. So I don't know if the spreadsheet is visible on the screen, but I hope it is there. Can you confirm?
Yes, yes. Okay, so we have to make a screenshot of it in the individual report, right?
Sorry, can you repeat that?
We have to make a screenshot of it on
No,
the
you have to submit the original file, original spreadsheet, the mass data sheet.
Okay, so in our individual report, we will have a link.
Well, you can submit that as a part of your assignment
Okay.
submission. You can attach multiple files within the
Oh,
MS Teams
okay.
assignment turn-in section. But what is important is that you can still use a screenshot of what you did, because if you are explaining what you did, and that is the objective, you're supposed to talk about the identifiers and quasi-identifiers in terms of whatever data set you had, and talk about why you masked them, the way you masked them, what was your use case, and all of that could be best explained by having small screenshots if possible. But it's not
Okay.
mandatory, because I would have your spreadsheet anyway, so I can open your spreadsheet and cross-check. But if you're asking me what would I do if I am at your place, in order to make my report better in terms of its quality, I would include specific screenshots if I have to, for certain decisions that I have taken.
Okay, thank you.
All right. Is there any other question? Yes,
I
Phil?
have a question. So are we still making the presentation? Are we going to make the presentation today, or we will send only the
I
results?
already answered it in the first part.
You said we can't do the presentation until we finish. So, but we're adding these ones. Are we going to do what we have done so far, or
What
we'll
are we
just send?
adding? We are not adding anything. I'm afraid I think we are on a different frequency here. What you see on the screen is already assigned to you as an assignment. The deadline is Monday by midnight. You have the complete Monday
27.
as well,
Yeah,
right?
but you
Now,
said we should
there
add for
would
the.
be, pardon me, there would be another assignment that would be the third part that I would assign you as well. I'll talk about that a bit too. That is all about your individual report. About presentation, there would be none until we cover everything. And once we cover everything, I would announce the date for presentation separately.
Okay, I was just a bit confused because for section 5, you refer to the group work. So I was wondering if we are adding this also to what we have worked on, but I think I understand.
I see absolutely no reason for confusion, to be honest. It's essentially not a remark, a direct remark, but just my view, because all of this is something that you could work as a part of group, as far as taking suggestions are concerned, brainstorming together, but you have the autonomy to submit your work individually. That is a premise that we have set in the very first session. So essentially, yes, you can work with whatever manner you prefer, with your group or without your group. It's up to you. That's your call. It's unrelated to me. I have kept the door open, and I welcome all of you to discuss all these activities with the group, because this is what you would be doing in practice. In any organization, it is highly unlikely that you would work alone. You would work with a team. So work accordingly and prepare yourself. About presentation, we will have separate guidelines, instructions, and don't worry. And it's about everyone, because other students may have had this kind of confusion. I understand there was a gap in between, but nevertheless, you would have instructions accordingly when the time comes. Now, I have a quiz that you all have to attend. But I suggest we take a break of around 10 minutes and then have a quiz. Is that fine? Again, I see none of you, all of you have gone, so absolutely no faces. But I'm gonna note this down in the chat.
Just a quick question. The quiz is going to be what format and what?
Come again?
The quiz is going to be in what, like the one we took the last time on the topics we've covered today?
Yes.
Okay.
All right, I hope most of you are back. Um, already 16:09, 2 minutes past 16:07. The reason I wanted you to be here sharply at 07 is because for the quiz that I would conduct, there is something important I would like to highlight, and that is the setting we are in right now is, of course, a setting that is ideal for essentially using a ChatGPT or any AI assistant that you may use, or just use external reference. But the concept is that the quiz should be done without using any of them. It should be a closed book scenario. So I won't go into the details of how I could control that, but bottom line is it's not really possible. So I would be trusting you, essentially. And this also means that you would have to be honest. I don't want to be some kind of a lecturer of telling you what you should be doing exactly, but as a teacher, this is my expectation here, and I want to lay it out very clearly that I am relying 100% on your honesty. I may ask you to share your screen randomly. All of you should keep your cameras open. That's a requirement. I still see 4 of you who haven't opened their cameras. I won't share with you the QR code unless you do that. Um, be aware with regards to the completion of this quiz. If I have any oddities in the result, as in results that gives me flags of AI usage, I reserve the right to not accept your quiz. Bottom line remains the same. If you are 100% honest, that is what I would expect and would take it as a suitable response. So I see all of you, and I would now share with you the QR code. On top of that, I will be publishing the link in the chat section. You have essentially 10 minutes to complete this.
Do you have to start now?
Yes, your counter isn't started. I'll just move the counter on your side. It would make it a bit more visible. 3 more minutes. 3 more minutes.
Sir, we are in mute.
Sir, you are in the mute.
Sorry. Yeah, thank you. Thank you for pointing that out. What I was telling you is with regards to the last part of this course, I am hearing some echo. If you have anyone, right. So some reason my hearing echo. All right, it seems to be fine now. The last part of this course has a combination of two aspects. Number one, a conclusion of data masking with regards to different use cases where the re-identification could occur, and what is a suggestion with your situation, as in how would you deal with that scenario to ensure a level of confidence. Second part is a compliance part, and be aware that I would quiz you on what I would discuss with you now. So pay attention. I would start by referring to the first case that I have, which is regarding a very famous competition that took place in around 2006. And it was organized by Netflix, where they had different competing teams competing together for predicting the ratings of users uh, by coming up or proposing an algorithm that could do that with high accuracy. Netflix provided a data set, a very big data set with around 100 million ratings for about 480,000 movies, sorry, from about 480,000 users of about 70,000 movies. So we are talking about quite a big data set with around 500,000 entries pointing to data subjects, where the anonymization they applied was replacing the name of users with random characters and essentially changing some ratings with fake ones or artificial ones. Fast forward 1 year later, there was a publication that was made by a group of researchers who found essentially a mechanism by which they completely re-identified all of the data subjects, which was a massive issue because, again, the number is quite high. And what they did was they essentially took at another published database that was done by IMDb. I don't know if you have heard about that website, but it's quite a famous website that also has ratings of movies and similar aspects on which Netflix was working on at the time. And they linked the publication from IMDb with the publication that was made by Netflix. And by linking them, they were able to essentially re-identify all of the data, which is a good example of when I said to you in the last slide deck what happens when we talk about dealing with data sets that have never, or in other words, highly unlikely any guarantee of providing complete assurance that they would never be re-identified. There are always issues, and some of the issues stem from number of known attacks, one of which is a linkage attack. I would come back to this, but you might be wondering, this sort of re-identification would require scientists to work together and find out some correlations. Actually, it's not that complicated. I have another example here. If you look at this list here on the left side, it has taken from a science journal, and on the right side, the snippet has been taken from a newspaper. It corresponds to a scenario where on my left side, or on the left side of this screen, there are some identifiers that corresponds to an individual pertaining to some sort of accident that has happened.
We can't see your screen.
Yes, sir, we
Okay,
can't see
got
your
you.
screen.
You should have told me before. Okay. Thank you for finally pointing this out. Is it the case now? Is it the case now? Okay. Well, quite a surprise. I don't know how I would recollect what I was talking about, but quickly, this was the slide I was referring to when I was talking about the Netflix competition and the way after 1 year, the re-identification that took place based on number of linkages that were performed by the researchers. And I was referring to the fact that this may appear as a kind of activity that scientists would do. And you may ask yourself, well, if we are up against scientists, then of course we would gonna end up losing. That is, of course, jokes apart, not really the line of thinking that you should have, because when we talk about re-identification scenarios, this is a classic example that serve as an example to support the idea that you cannot provide 100% guarantees, aligned with what I was saying in the previous slide deck. And second, that this is where the need of risk assessment or checking your anonymized data set against known attacks becomes of paramount importance. You have to ensure that you cross-check or analyze it again and again to ensure a level of confidence. Now, what I was referring to afterwards is the fact that when we look at other scenarios where you really don't have to be a scientist to perform any kind of comparisons, I have an example in this slide that refers to, on left side of the screen, a snippet from a science journal, on the right side, a newspaper. And they both refer to an incident that took place, but on my left side, the science journal has anonymized so-called the record that was published. Now, the reason why it is regarded as an anonymized set of record is because this essentially is where we have had the name of the individual completely removed from this entry published in the Science Journal. But if we take this entry in the Science Journal and compare it with the news snippet that was published along the same timeline within the same region, we can actually cross-check number of areas. And if I start with the address of the hospital, it aligns with the address that was included in the snippet. The timing also aligns with the timing mentioned in the news snippet. Emergency data aligns with what we have in the newspaper. Same goes with the age and the address. Now, if I can compare all of them, it is not very difficult to find out the name of the data subject that was essentially being masked. And this means that when we talk about data masking, this is the kind of scenarios that you would be dealing with quite a lot as well. You would be ending up in situations where things like this, a comparison could occur and re-identification would be possible without performing any sophisticated or otherwise very scientific analysis. This could be done by anyone at any given scenario. So coming back, therefore, to the necessity of having some kind of risk assessment to be done always once we anonymize a data set, is because there are a number of known attacks available. Background information attack is where an adversary might use existing information about data subjects to infer additional information about them and therefore re-identify attributes that were masked. Unsorted matching attack is more about essentially trying to attack the order in which the tuples may appear in the release dataset. The tuple is a combination of three connected data points. A good example that a lot of students always get is thinking about a URL address. It starts with the name of the protocol, HTTP, then the name of the domain, and then the path, and lastly with a port number, which is typically not visible. But when I talk about tuple, any data point that you could imagine that could only work in conjunction. For example, another example along the same lines would be your address, which would always have the name of the building. Well, what I mean by name is actually the number of the building or the apartment, the name of the street, and the name of the city. These are the type of data points that would always appear in conjunction or together. So tuple is typically for three data points that appear in conjunction. An unsorted matching attack tries to attack that order or break that order. We have complementary release attack where we might see, and something, by the way, which was quite common during COVID-19 times. A lot of research was published by a lot of institutions out there, and those research papers involved data points of data subjects that were essentially from the same set of people. For example, there were 5 institutions across the European Union that were trying to conduct different tests on the same population. And each time they were publishing the data to the public, uh, essentially they were making it more plausible for a third party to re-anonymize that data set because each of the publication was essentially acting as a complementary to the other one. In other words, an adversary could take all of the publications or releases out there and link them together to compromise whatever anonymity there might be, like k-anonymity. Then we have temporal attack, which is more about adding or removing, again, the order in which the tuples occur and trying to see if we can break them and try to link them with other data points. The point is, I cannot list all of them. There are many of them, but this is where it becomes essential to make sure each time you publish data set, you have performed enough risk assessment. And this is where you would be dealing with your technical team specifically to make sure that they have enough confidence that what you have anonymized is aligned with the current landscape of threats. These are just few of the attacks, but your technical team should be able to comment on other threats that might be applicable to you. I have seen, by the way, organizations often refer to third parties. I was talking about AirCloak in the previous slide track. That is one of the organizations that I have seen people reaching out. But the reason they often reach out to a third-party organization is because this allows them to transfer the risk of liability. And this is also quite common in practice. So the point or the bottom line, I would say, is that data masking is not the end goal. Once you mask your data, it is essential to assess the masked or anonymized dataset to ensure it is not vulnerable to any of the known re-identification attacks. With that, I have a quick flash of the threat categories that we discussed about Linden, and I also introduced you to other types of threat categories. I remember CIA being one of them, Strut being another, but I would like to just bring you back to the closure of privacy by design scenario, which is based on the ad hoc approach I told you about, as in one overarching goal, 6 strategies, 3 phases, and out of those 3 phases, the second phase is where we apply 4 strategies or 4 activities that involve all the strategies. In practice, this is what I suggest you to do. This is what I have been suggesting to other students because it is based on a research paper that has been widely peer reviewed and accepted to be a very good approach. It also won an award. I don't know if I gave you the reference of that. But if you're working in an organization, let's say, that has very high primitives, for example, they would like to comply with ISO 27550. This is one of the data privacy focused ISO standard that a lot of people don't know about. People mostly know about 27001, which is more about security. But 27550 is one of the compliance requirements where your company would like you to use established systematic engineering framework. And this is where I talked about Linden, which is not just different threat categories, but actually a full-fledged system of defining the problem space by starting with the high-level diagram, but going into low-level details eventually, forming a data flow diagram, mapping all the threats, identifying all the threat scenarios, and finally finding solutions. Other factors also involve not just looking at the one complete cycle of operation, but looking at multiple states of data when they are, for example, in a database or stored as a backup on a third-party site. Lastly, it's important for me to be very clear about the fact that it doesn't matter how sophisticated your data masking technology is. Some of you might work in an organization which would have a very amazing pipeline of applying data masking through state-of-the-art privacy algorithm. But if the same organization has a server that is applying state-of-the-art privacy being not properly protected, as in the server was not kept up to date with security updates, for example, then the point is no security guarantee, or I would rather say no privacy state-of-the-art solution would help the privacy process to be compromised. In other words, there would be no security guarantee at all. Hence, it's important to note down privacy and security go hand in hand. If you have a state-of-the-art privacy algorithm but very poor security practices, they would eventually defeat the purpose of having very good privacy. In fact, privacy would mean nothing if your server is compromised. So what is important is, as someone who is looking at it from a non-technical perspective, you should be aware that you are working in conjunction with technical teams, and in technical teams, your participation, as far as your suggestions and proposals are concerned, should be directed towards ensuring a balance between data privacy and security. Because if you have amazing privacy protections but are doing very poor on security level, you would have eventually a compromises defeating the whole purpose. Now, the last part is GDPR, which is the regulation that is very important to discuss. It is not something that was essentially part of data privacy by design topics, but it has been included because data privacy by design has been mandated, obligatory slash, if you like, to be done, and GDPR is exactly what does that. If you reflect back to the first slide deck, I also included the official reference of the article number. But what is GDPR? GDPR is essentially a regulation, General Data Protection Regulation, that came about in around 2016 as a draft. It came into effect on 25th of May 2018, and it repealed the existing Privacy Act that was essentially from 1995, quite an old one. What is important to note down is that GDPR is a standalone regulation that is not linked with different other laws or regulations that we have in place. And a lot of students often confuse them, because when I look at their questions, it appears as if they are confusing GDPR with, for example, do not call me list, something that you might already know or something that you might already be aware of, because it is where people get call from a marketeer trying to sell them something, and they, for example, do not appreciate receiving that call, and users or people have the right, as per this rule or law, I would say it's actually a law, that people could ask the marketeer that the marketeer should exclude them or their personal data from their list. It has nothing to do with GDPR, or in other words, you can't invoke your GDPR right just for that. You can use the existing law. There are separate laws for protecting national register numbers. There are e-commerce laws, cookie policies, something which is quite interesting because when we talk about managing how our online behavior is tracked using third-party cookies or third-party trackers, we have to realize it is not the GDPR that is essentially controlling all of those trackers or regulating those trackers. It is actually the cookie policy, which is essentially a separate law that talks about how those trackers should be managed or regulated. E-privacy, a very interesting directive slash law, which involves, for example, something that you can relate with directly, and those are the cookie banners. Each time you visit a website, you might have seen a cookie banner, which might annoy some of you because most of those cookie banners are supposed to provide us a very clear way of opting out, as in reject all or accept all or do not agree, something like that. But what you might have also experienced is that those cookie banners might include a very difficult way to opt out. comparatively to a mechanism to accept all, as in a single button to accept all, but in order to opt out, you have to click on select few, essentially switch off or uncheck certain boxes, and that is something which you would be surprised to hear that e-privacy actually has very clear guidelines on what should be done, and those are something that have been translated into separate laws as well. So that is something which is not directly related to GDPR, and there are a number of other regulations. So that's the first thing. GDPR is something that is there as a standalone regulation. It complements other rules or regulations or laws, or those laws, regulations, or rules complement GDPR, but they essentially are standalone pieces of, let's say, legal text to abide by. Moving on with GDPR, which is my focus, I have to highlight why we have GDPR. Can't we just live with that Data Privacy Act that we had since 1995? And to answer it very shortly, I have here on the right side of my screen the result of a barometer. A barometer is a term that is typically used by European Commission to publish results of the survey. And one of the surveys that was conducted that is officially referenced in this source was asking people how much control they feel they have on the online data that they share. And you would be surprised to know that only 15%, a very minority percentage, essentially said that they feel they do have complete control over the data they share. The vast majority said the complete opposite. Now, this is quite clear in terms of what people, especially in this region, have a view towards data privacy, and the general expectations is that the data should belong to the subject, and the companies should have mechanisms in place to handle the data with secure and private mechanisms, and they should adapt, as in organizations or companies should adapt the way they work with personal data, so that they do not collect additional data points, as in only connect data which are required for the corresponding processing activity. What is essentially the goal? Of course, to translate all of these expectations and the results of the survey into a regulation, a law that the state could control and enforce. And this is where GDPR comes in. There are interesting terms that you would see a lot in GDPR. PII is one of them. I have been employing PII at all. So PII is personally identifiable information. Keep in mind, a lot of students often confuse PII with direct identifiers. It is not just direct identifiers. It is actually both direct or / and indirect identifier. As long as there is personal data that could be used to identify the subject, either in combination with other data points, meaning indirectly, or directly, as in without combination with other data points, it would be regarded as PII. So a very common interview question that you may also have, because I have seen some students facing this in the past, is what exactly is PII? And those students actually fail to answer them properly, because they often end up saying, well, it's any information like first name, last name, email address. Well, no, that is not the case. You should answer, it could be any directly or indirectly information corresponding to a data subject. Now, there are some special categories that GDPR has highlighted. I have listed them here. You can read them, but essentially the reason why GDPR is treating them as special categories is because GDPR brings additional responsibilities to the data processor and data controller, who would deal with data for the processing when the data includes any of these sensitive categories. About data subject, we all, I think, have already got the idea, because this is another term I have been using here and there. It is about any individual or any entity that the data belongs to. Then we have controller and processor. These are very GDPR specific terms. I mean, PII and sensitive categories of data, data subject, these are the terms which you would often also find in context other than GDPR. But data controller and processor was really something that came with GDPR as far as I understand. And it is quite straightforward in terms of being a controller, having or being any entity that determines the purpose of processing data. In other words, if you look at it from your Epita's Office 365 account, this is an account that is based on a service provider known as Microsoft Outlook. But this essentially is a service provider that has been taken by or opted by the Epita as an organization so that they could process your personal data or allow you to have certain functions like sending, receiving emails, using MS Teams, and so on. And this is where Epita is acting as a controller because they are essentially determining the purposes and means of processing activities, and the processor is Microsoft Outlook. Similarly, if we look at your students' portal, this is a platform that is managed by a third party. It's completely outsourced. But if you look at it, who is the controller? Who is the processor? Well, it is Epita being the controller who is managing the processing activities to be used or actually executed by the processor. And the processor is essentially an entity that is processing the data or executing all the processing activities on behalf of the controller. What kind of processing activities? Well, any manipulation of data, to keep it short. And I have written down here collection, recording, holding, transferring, carrying out any sort of operation. So in short, any manipulation of data is processing of data. All right. With regards to another term which you may find commonly is DPIA, Data Protection Impact Assessment, which is all about essentially conducting a kind of risk analysis when we are dealing with data, personal data, let me be precise, PII, where the processing activity is likely to result in a high risk to the rights and freedoms of natural persons. This is a quotation taken from the GDPR legal text, and this indicates to the fact that if a processing activity, for example, take a data controller, which is a hospital. A data controller being a hospital who is performing some sort of processing on PII, let's say for the sake of any research that they are conducting, and the PII involves identifiers pertaining to all the patients that they are conducting their research on, it is essentially a kind of activity that is likely to result in high risk of rights and freedoms of the patients that the PII is corresponding to. And this means we as an organization, as a data controller, is obligated to perform impact assessment report. This is based on essentially filling out a template that is given by Data Protection Authority. In fact, in your last exercise, you would be asked to also download another type of template I would talk about. But I have here a screenshot that I took from one of the tools that I used for one of the clients I had in 2018. And it is OneTrust. This tool is still there. And in fact, they have enlarged their operations. But what did I do exactly back in 2018? Well, when I was using this tool to conduct a DPIA, they presented me with a list of questions. And I filled out all those questions. They provided me a result, or if you like, a verdict, which is whether you should conduct impact assessment report or not. And then I essentially conducted impact assessment report where I analyze how much of risk is involved in processing activity 1, processing activity 2, depending on the type of personal data they were processing. So it was quite a long list of essentially what kind of options I had, but the bottom line is it is a kind of term you would be facing when dealing with GDPR. In fact, you might be required to conduct DPIA. It is a good practice, by the way, to assess the risk and evaluate the technical or organizational measures anyway, because this is exactly something you do in activity number 3 and 4. And this could be done at any point in time for any activity, meaning you should have been doing this already in the past if you have applied privacy by design. But you are obligated to do it as long as you believe there is a high risk of privacy to the PII of individuals you are dealing with. Next is a list of terms that are quite related, and some of which is overlapping with other as well. So starting with DPO, this is essentially a protection officer or data protection officer acting as an official individual or a team of individuals that is responsible for maintaining the accountability. It is mandatory under areas where we have hospitals or organizations that deal with high levels of sensitive data. We then have another interesting term, which is DPA, which is where it overlaps with another term that is data processing agreement. Now, data processing agreement is a contract between a user and the data controller. In this case, DPA is a data protection authority that is designated by the state. For example, in France, the official data protection authority is CNIL.fr, the website where you can visit the resources by this DPA. And all of these DPAs from different European member states, because every European member state has its own data protection authority, is essentially in conjunction with European Data Protection Board tries to implement GDPR. What I mean by in conjunction with the European Data Protection Board is that European Data Protection Board acts as an independent body that provides advices, opinion papers, and references to cases where they believe that different DPAs are not acting in a consistent manner. So if I have to really summarize into one sentence with regards to what EPDP does, it tries to harmonize the efforts of GDPR implementation across the EU member states. With regards to scope, where exactly GDPR applies? Well, as long as the PII or personal data of an EU resident is processed. We don't care where it is processed, whether it's inside one of the EU countries or outside the EU countries, as long as personal data of EU residents, and by residents, I'm also not only referring to citizens. If you don't have a citizenship, but a legal residentship, you are still covered by GDPR. So any EU resident whose personal data is processed is essentially protected by GDPR. Another aspect that was noted in the regulation, it is something that I have seen professionals not really focusing on, but I always include this in my discussion with students, and that is anytime the behavior of an individual is monitored. For example, if you are at the airport, you might be watched by cameras from every single angle, and they would be continuously monitoring your behavior because they are programmed to flag any traveler with unusual characteristics or behavior characteristics. And this is what I mean by monitoring. So thinking about cameras or facial recognition based cameras or any such activity where monitoring of an EU resident could be done is also covered by GDPR. Now, I am not a GDPR lawyer. I am very clear about that. That is not my domain. I am only giving you specific points about GDPR from the perspective of privacy by design as a professional. The reason I'm doing that is because these are the points that, in my experience, every organization have to follow. There are no exceptions. You cannot say, well, we can't do this or do that. If you do this, you will have a problem. GDPR is a very lengthy text. We're talking about around 40 pages of legal text. And of course, I can't sum it up into this small session. So I have taken around 9 points, the core points. I often use the term that these are the legs as an organization you would stand on. If you have no legs to stand on, you would not really be GDPR compliant at all. So starting with the very first and the most important one, and that is every processing activity should have a lawful basis. GDPR introduces 6 lawful bases, and the goal is that you must determine which lawful base apply to which processing activity. For example, if it's a marketing exercise that you are performing that involves personal data, you are required to first determine if it's consent, for example, taking permission from the user. Then in that case, you have to ensure that you document this lawful base before conducting your marketing exercise. Same applies to any other processing activity. A good place to document this is your privacy policy notice, terms and conditions, or any other document that you may use. But be aware, you must have a lawful basis for every processing activity, which you should document before conducting the processing activity. The second is data privacy by design, a specific article in GDPR, and this is the page that I don't really want to talk about because this is exactly what we have discussed throughout this course. So if I have to put it very shortly, I'm talking about the overarching objectives, 6 strategies, 3 phases, and within those 3 phases, the concrete 4 activities that we performed. In other words, you are obligated to perform that. You're not dealing with that as an optional thing. You would be required to do so as long as you would be dealing with personal data. Then the third point, a very important one, is individual subject rights. It is a table that I created, and I spent actually months in creating this table because I had to actually take some feedback from lawyers, as it was not clear to me whether what rights of individuals are available based on the legal basis that has been selected by the controller. So, so far, to the best of my knowledge, this table is accurate, but GDPR is a moving target. Things improve, things might change over time. So if you look back to this slide after 5 years, be aware this might not be up to date. But as we speak, consent provides all the rights except right to object, so right to access, right to rectification, right to erasure. This is quite an interesting one because most of the requests I have dealt with is the right to be forgotten. Now, forgotten is just another term for erasure. People want us to remove all of the personal data we have on them. Then right to restriction, right to portability. People want us to let them export all of their personal data in a structured and standard format, something we discussed in the very first lecture, so that they can migrate to other place or they can store their data and so on. Right to object. With consent, user can withdraw their consent instead of objecting to it. The idea is if you are permitting someone to do something and then you have an objection on it, then you can revoke your consent, and this simply means you would be saying goodbye to the service. The service provider would say, all right, you are more than welcome to leave our service if you don't give us the permission. Nevertheless, I have here all the corresponding legal basis with the rights that it provides. What is important from an organizational perspective is that the organization should be ready to execute these rights because there is a hard deadline of 1 month. If an organization doesn't respond to your request, one of the requests that GDPR gives you the right of, within 1 month, you can actually launch a complaint against the organization with the Data Protection Authority. And that's very problematic because if there is one complaint being launched at DPA, you would become essentially one of the focal points of the DPA. DPA has to, of course, focus on thousands of different other things. But the idea is that as an organization, you should have the necessary technical procedures to be able to let people execute or exercise their right of erasure, portability, rectification, and so on. Then I have some points. 4 being documentation. This is something I can emphasize quite a lot on because the very first thing a data protection officer would check when he or she would visit your organization, let's say to a surprise visit, that would be the processing register. something that you would actually download from the CNIL website for your last assignment, where you should list down all the processing activities that you are doing, documentation about who's the right point of contact, processing agreements, protection impact assessment reports. The point is, for accountability and governance, it is important to ensure you have sufficient level of documentation done, and the primary document is always your processing register. Make sure it is ready. Make sure if you are participating in updating the processing register, you do your best, because this is really what would save you from any unwanted or undesired situation of getting fined by a data protection authority, for example. Then we have an obligation of ensuring that if our data is being transferred outside of EU, if there is any sort of cross-border data transfer taking place, then the receiving organization should make new contracts or essentially update existing contracts. And I have had an instance where one of the clients I had had a branch in Turkey, and we had to then update all of our existing contracts with them because data was being transferred to them, and they had to ensure in writing within the updated contracts that they are respecting GDPR to the right level of expectations that we had. Then, of course, security, which is all about ensuring that your protection measures are sufficiently covered by the corresponding security protocols. Again, the point is GDPR is quite open about it, that if you have state-of-the-art privacy algorithm, but the server is not up to date with security patches, then your privacy wouldn't mean anything. Your server would be compromised. Lastly, data breaches, something which is quite crucial. In case something bad happens, you as an organization acting as a data controller has a legal obligation to inform the data protection authority within 72 hours. Be aware this is a hard deadline. Not only that, you're also expected to inform users whose personal data has been impacted by a breach, but make sure DPA is informed within 72 hours. What happens if you don't do so? Well, there are high sanctions and fines. I have some examples here on my right side of the screen, and these examples should be clear in terms of the fact that GDPR is not there on paper. It is
Sir,
actually happening in practice. Yes?
sir, time is up.
I know, Jatin. Thank you for reminding me. Great. Amazing
No, no, no,
contribution.
No, sir, in the
Thank you
group
very
they are
much.
posting.
Well, all right. Thank you very much.
They are posting in
As
the
a,
group, time is up like that, sir.
all right. Yeah, again, thank you. Thank you very much. Amazing contribution. But I'm very well aware of that. I'm taking the liberty to stretch it because I would like to cover this. Uh, okay. Now, with regards to the fact that GDPR is there being enforced, here you could see an example of fine that is imposed by an Irish Data Protection Authority of a value that should shock you if you still believe GDPR might not have a strict impact. There are two levels of fines. One is about a maximum fine of around 10 euros or 2% of the annual turnover. And let me tell you, that is already a death sentence for a small startup. If the situation is severe, let's say the organization didn't even inform the DPA after it got compromised within 72 hours, the DPA might ensure that they receive a fine of up to 20 million euros or 4% of annual turnover. This might gives you some explanation of why Meta was fined for this magnanimous amount of around 4 billion euros. Then there are some aspects. I'm closing this discussion now, which I cannot really cover because the points that are quite clear to me is the point you see here. If you are processing data that corresponds to minors, GDPR is very explicit that the consent, if you are using consent for the processing activity or of collecting their personal data or managing their personal data, then it should be taken from their legal guardians. The date of consent, the age of consent may differ. Some countries have a different consent versus the other countries. But this is another aspect that is not often discussed. I have seen a student just like you who was preparing for his mobile application. and the mobile application was essentially something that was collecting data of children, and I discovered that the consent was not taken properly. He was actually in violation of GDPR. But that's again something that you would have to keep an eye on. And there are some unclear areas. I'll let you read that tweet if you haven't read it already. You can acknowledge if you have read it. All right, I see few acknowledgements. Now, those of you who have read it would got the point. It simply means that I am saying that there could be scenarios, just like a scenario where personal data is stored in a blockchain, and we receive a request from data subject asking, please remove all of my personal data. Well, we cannot remove anything from blockchain. That's something that won't work. It's against the design of a blockchain. So this is a sort of thing that is still unclear. The point is GDPR continues to evolve. In the final slide that I would publish in the MS Teams group, I have all the reference of the links and external sources I have taken for preparing this course. And in that, I also include links of the websites that I personally use to keep myself up to date, one of which is noyb.eu, noyb.eu. But nevertheless, the bottom line is, to sum this all up, to close our discussion on GDPR, is that if I have to really put it down into a kind of a mantra that you should keep on your fingertips, is number one, be aware data subject rights have been widened, and you are really, as an organization, be ready to support exercising those rights by having necessary technical measures. Be aware you only have 1 month to reply to a data subject. If you past that 1 month, you're opening yourself up to a lot of trouble or potential fines from DPA. Then document everything. As I said, this would be the very first thing a data protection inspector would ask for as soon as he comes to your organization. So data handling procedures, incident response, and on top of that, your data processing register should be ready, up to date. Lastly, stay prepared. Keep on improving your technical and administrative procedures to ensure that this is something you could proceed to support in case you have an audit or in case you have to just signify GDPR compliance. Be aware GDPR compliance is something that would not only allow you to be legally compliant with the law, but also it would foster trust. Why? As we saw in the barometer, the survey, people, a vast majority of them would feel more comfortable to using your service. In fact, you as a marketing team or a content team could capitalize on the value of privacy, because this is not just a concern anymore. It is a business asset, a strong business asset that you could capitalize in terms of putting added values to your product. So that's it. This is the last exercise that I have that I would assign you, but with an extended deadline, not by Monday midnight. It would be by Friday midnight typically. But here I'm asking you to essentially focus on the compliance aspect. From GDPR side, you would be taking up the table in the first section. What I mean by taking up the table, you would create a table with 2 columns, PII and the purpose of processing. PII should be divided into direct and quasi identifiers. And this should be based on the spreadsheet I provided, I gave to you. The second is downloading the processing register. The link here brings you to the official website of cnil.fr, where you could download the official template and then use that template to fill up all the processing activities. Is there any question about the section 7, 2 actions in particular? All right. I think if you have no question, then I can stop. It's already 12 minutes past the time of the class. I started late, actually. I started 15, 17 minutes late, so I was kind of extending the time, but I have one little I have one little favor to ask from all of you, and that is if you can go through the very last quiz, which is where I would ask you several questions about GDPR discussion to essentially stop this discussion and complete this session, which means I would hardly take 10 minutes more, 10 or 15, I don't know, but that is a favor that I would ask you. Would it be fine?
Okay, sir. Okay.
Um, I'll share with you the link, but in the meantime, I will just take a few moments to inform you about the final presentation. And also the fact that there is one attendance sheet that was not present when we had the course. So starting with the presentation, you would receive the detailed instructions by post. I have 3 groups in this batch of AIMS, and I would send you MS Teams invitation. It would be online, not in person. All the instructions about what you would have to do, exactly how much time you would have, and other core areas of your focus would be explained there. So that is about that. With regards to timing, I would be respectful towards your timing, as in not to overburden you with a lot of things at once. I would let you complete the last assignment, uh, uh, which is section 7, which means that the assignments would be submitted by next Friday. Once you submit that, then I would give you a time of at least 1 week to essentially complete the presentation. So you would receive the so-called invitations, concretely calendar invitations for dates after the next Friday with a gap of 5 days. And if you think you're not available, of course, I would be open to find a suitable time to manage this uh, in a manner that would suit you. All right. With regards to the spreadsheet of attendance, I would open this in a moment. I'm just finalizing the quiz that I need to share with you. All right. So this is the link of the QR code of the quiz, and I would be putting the link in the chat section. Yes, Pervez?
Sir, is this another quiz that we have to attempt right now?
Yes, yes, yes.
Okay. Sir, can you please share the link?
I have already done so in the chat section.
Chat. Okay, okay. Thank you.
I have also put the timer on a screen. It goes without saying that the drill is exactly the same. I am relying 100% on your honesty. I see some of you were laughing a lot when I was at the end of my course. Perhaps you had an amazing joke around that time. But for me, the most important thing is your learning outcome. And from that perspective, just be honest with your answers. It's not just you preparing for this course and get some grade, but rather preparing for the real life. So just test yourself honestly. I see 3 students, well, 4 students that haven't turned on their camera. During quiz, please keep your cameras on.
Sir, you're on mute.
Sorry. Thanks, Harini, for pointing that out. I was referring to the fact that for those of you who have completed the quiz, I at least see 2 of the students who have done it. As soon as you finish the quiz, you're free to leave because we're already around 20 minutes past the official time, so I don't expect you to stay. But I will be here after the call just to address any questions that you may have to make sure that you have nothing left unanswered. Before leaving, be aware that the attendance sheet for the 8th of October, the day when we didn't had the attendance sheet by the administration, is now open, and you can mark your attendance about that too before leaving. Again, those of you who are completing are free to leave. I am still here in case you have any questions.
Thank you very much. Goodbye.
Bye-bye.
Thank you, so mark my attendance and
Thank you.
complete the
Goodbye.
quiz. Thank
Should we
you.
type
All right.
present again?
Sorry, Zirwai, you had a question?
Yeah, I said, should we type present again on the message?
Can you elaborate? What are you referring to exactly?
Thank you very much for that.
Zirwai, can you hear me?
Yes. Oh,
Did
sorry,
you?
my My mic wasn't work.
No problem. I asked you to elaborate because I didn't follow your question clearly.
I mean, should we type present again on the text?
No, not for this session. I already have a clear view and I already closed the attendance sheet for this session after 15 minutes. So it's fine and it's okay.
Thank you so much.
No worries. Thank you for the additional time.
Bye.
Bye. All right.
So like
I
I,
would
so like I wanted to ask about this.
hold on
How
just
we
1
can
second.
just mark. Okay.
With regards to the quiz, I'm about to close it. I have received around 10 responses, but within 20 seconds, I would close it because the time would be up. So if you haven't submitted it yet, please submit it now. I'm about to close the quiz in 5, 4, 3, 2, 1. Okay, the quiz is now closed. Yes, Jatin.
So I was asking about like how we have to mark the attendance of 8th of October.
Well, as I said, and I understand you were probably doing your quiz at that time, just as you mark any other attendance by going on to the attendance portal, looking at the right entry, the attendance sheet is open. Okay?
Okay.
I
I'll
see
just give a
you
try.
were enjoying a bit as well during the session.
No, not enjoying.
Well, I could follow that. You and I think Hannah and 3-4 students were laughing a lot. So I hope you had a good time. But be careful during presentation. I would be having a good time because I would then have the opportunity to ask you questions. So prepare well is my message.
Sure.
Okay.
Thank you.
Thank you,
Okay.
sir.
Sir.
Thank you for good day. Have a
You too,
good weekend.
Venkata. You too,
Thank you.
Venkata. Thank you. Bye-bye.
Thank you, sir.
Sir,
Thank you very
just a
much.
quick one, sir. Like
Yeah.
I had saved it, like my page was loading. Like was it saved? Because then I
Talking about your quiz,
yeah.
quiz 3.
Yeah, that just now like
Shemaya, yes, I confirm receiving your quiz.
okay, sir. Thank you, sir.
All right.
Yeah. Thank you so much.
Thank
Have
you,
a good
sir.
weekend.
You too.
All right,
Bye.
sir. Thank you so much.
All
Bye-bye.
right. Bye-bye. Hamad Pervez, I'm going to close the call if you have no question because everyone has left. I believe you are not there. And I'm going to close the call now.